Hi all, in this session we are going to cover 5G SSC mode selection process. So in our previous session on SSC mode, we defined three SSC modes, that is fixed, break before make, and make before break. But these are not just assigned randomly, and the process shown here is the decision making flow that happens in milliseconds during PDU session establishment. In step 1 we have UE is going to initiate the request. So it starts at the UE, like when a device initiates N1 NAS PDU session establishment request, it does not just ask for data, it evaluates its own application needs and the hardware capabilities. And UE is going to include requested SSC mode, and along with it, it is also provide that as an SSAI ID, or you can say slice ID, and the DNN, which provide a context for the request. However, it is very important to remember here, the UE kind of request is just a suggestion. Now, in the step 2, we have the subscription data retrieval, you can say. Now, once the IMF passes the context to the SMF via an SMF PDU session create SM create context service. So the SMS first job is to job is like a context check for that particular request. So here SMF is going to query UDM, that is Unified Data Management, using an UDM SDM get service. Here UDM is going to return the subscriber profile, which contains the two critical fields, that is allowed SSC mode, like a list, for example, subscriber is permitted to use SSC mode and mode 1 and mode 2, and but not mode 3. Also the default SSC mode, if it is the fallback if the UE's request is missing or invalid. Now SMF is going to relate that particular request. So here SMF is takes three inputs. Okay, it take consideration from the UE request, the UDM allowed list, and the local operator policy, you can say. Now the decision hierarchy looks like if the UE requested mode is in the UDM allowed list, SMF is going to use that particular request. And if the UE request a mode that is not in the allowed list, or in that case, SMF is going to assign the default SSC mode from the UDM. Also, we have a local operator policy that can override everything if the network is congested, or the specific DNN requires a specific mode for that, for some kind of technical reason. So in that case, SMF can ignore both the UE and UDM to enforce the operator defined mode. The next one is the UPF selection and session binding. Now here the selection is now finalized, and SMF now must select the UPF that support that particular mode. So if mode 3 make before break mode was selected, so SMF must choose a UPF that is capable of handling the new session and the old session overlap. And the SMF then sends the enforce session establishment to that particular UPF to lock in the user plane behavior for that particular session. And now if everything is okay, it will it is going to send that response PDU session create SM context response, and then last phase acceptance and notification. So here finally the SMF notifies the UE and the result. So it is going to send N11 PDU session establishment request to the IMF, which forwards the next message to the UE, and this message contains the final selected SSC mode. And if you suppose if you asked for mode 3, but SMF gave some mode 1 or mode 2, then in that case, UE kind of must adapt its application behavior accordingly. And after that, the PD session is active and the anchor rules are set until the session is released or kind of modify. And like one common question in this field like arises, what happens like if the UE doesn't support the mode, the SMF forced on it. In that case, like UE may like silently fail or immediately release that particular session. So that is why I like properly aligning UE capabilities, UDM provisioning, and the SMF policy is like very crucial for 5G optimization. And that's it from this particular session. I will see you in next session. Thanks.